So hi everyone, welcome to this particular video, and in this we'll be talking about GCP data engineering interview questions. It will be very much production ready questions that will be exactly asked to you in the interviews of GCP. Other than that, whenever you are going for, because see, there are major companies like Deloitte, PwC, many companies are there, many companies, good companies that they hire for GCP data engineers also specifically. So those things are already, like, I have covered all those kind of questions in this one. Major, definitely in one video we cannot cover end-to-end things, but I'll try to give you all those kind of information. Also I'll try to give you all those kind of understanding, because I've taken my pen tablet. I'll be explaining you everything from very scratch, from very good understanding of mine also, because I have been working as a data engineer from past 5 years. I've worked across many clouds, worked across various projects, various migration development projects. So core data engineering experience I have of 5 years. So definitely I am a good person to guide you, and I have been guiding people from past 5 years. More than 3,000 4,000 people I have guided on those data engineering aspects. So let's start with the things. As you can see on the screen, I have also opened my Google Cloud Console. Also, as of now, we have not enabled all billing. We have disabled our billing because that is not required as of now. That is not our motive. I just want to showcase you how the things looks like, and we have done many projects also in this, so we will be talking about that. Okay, let's start. So as you can see on my screen here, okay, so we will talk about this one first. Whenever you are going for a senior role, suppose you are going for a senior level role or a junior level role, type of the focus also shifts. The questions can remain same, but the depth of the answers, how much follow-up question can be used to you, that also matters. First one is architecture, cost optimization, scalability, production level, great thinking. These kind of things you should have if you are going for what? If you are going for GCP senior data engineering roles. Senior data engineering roles are for that we have to talk about these things. Okay, just okay, so first of all, we'll be talking about what interviewers exactly evaluate, because I have been taking many interviews also. I have taken lot of interviews. Okay, from past 2 years I have been taking interviews for data engineering and all. Definitely I have that understanding. Suppose I am an interviewer, I'll try to check basically, do you have an end-to-end understanding of the whatever technology you are skilled on. Next thing, do you also aware about, yeah, if I'll use this particular thing, what cost will be there? If I use these many type of computes, these many type of technologies, what will be your cost? Okay, these kind of understanding do you have or not have, that I'll be checking. Third thing will be the scalability and reliability. Very, very important to understand, because whenever you talk about scalability and reliability, you have a data like this. Today you have this much of data and 5 users are working on it. Your company grows. Now you have this much of data, and your users also grow to 100 or 1,000 users. Can your system, the code, can handle these kind of like this one, or it will fail with the memory, out of memory issues? Okay, so we have to figure out that also, those kind of things. So first question is, what is the end-to-end GCP architecture, analytics architecture? So whenever we talk about, there can be different kind of sources. Okay, OLAP systems are there, REST APIs, event streams, application log, all those kind of things are there for doing that. The second thing is, we also have a ingestion services are there, like we have GCS for batch processing, PubSub for streaming, we have event streaming, notifications we have to send, or PubSub for streaming. We have Datastream for CDC, like change data capture, you can do via Datastream also directly. Okay, for Snowflake it is streams. For directly, if you want to go for autoloader, is there for Databricks. Different kind of technologies are different kind of names. The concept of CDC, change data captures, remains the same. That is how you have to figure out the things. You have to understand those things. The third thing is processing. Whenever you are processing the data, what kind of services you can use? Dataflow, you can use Dataproc, whatever kind of workload. If you want to run your Spark workloads, use Dataproc. If you want to run your streaming workflows, use Dataflow. Okay, that is how you have to think about. Fourth thing is your storage. There can be, if you want to just on a data lake, you want to use object storage, any kind of data you want to process or load somewhere as a staging layer, intermediate layer. There you can use what? You can use Google Cloud Storage. Suppose you are working on analytics system, analytical system warehouse you want to use, so BigQuery, Google BigQuery is there. Google BigQuery, GBQ we talk about, GBQ. In majorly the resume keywords they will write as GBQ. So you also write full form Google BigQuery and also write GBQ in brackets. Okay, that is all, because that is how the things happen. Next thing is consumption. They also have like directly BI tools are there, data science notebooks are there, ML models are there for consumption, and all these kind of things are there. So this is the insight of how exactly things look like. Next thing people can ask you, that is what is the difference between a Cloud SQL and Google BigQuery. Google Cloud SQL is also there and Google BigQuery. These are the two different services of Google Cloud only. First one is Cloud SQL. Cloud SQL is an OLTP system. It is a row based storage, also called as OLTP system, online transactional processing system. It is built for transactions. Okay, majorly write heavy operations are there, operations are there, update heavy operations are there. So that is called as transaction, OLTP. Okay, online transactional processing. It supports your asset properties. It is vertical scaling. Limits are there, definitely. You cannot limit it or like increase too much. Okay, limits are there of scaling. Next thing is there of traditional relational. It is a traditional RDBMS, traditional relational database system it is. Then it is ideal for operational systems, like you have to store your metadata tables. So there you can use your Cloud SQL directly. Next thing we can talk about, that is BigQuery. BigQuery is an analytical system, that is OLAP system, columnar storage system. Columnar storage system is there and it is called a OLAP, online analytical processing. It is built for analytics. Okay, petabytes of data queries you can run. You can write a select clause on a petabyte table. Okay, that can be done. Queries can be done. Massive parallel processing are there because they are built as that. Serverless auto scaling is there. It is serverless. It can increase horizontally also, it can increase vertically also. Both of the thing can be done. Okay. Next, the petabyte scale queries are there, ideal for analytics workflows and all. So Cloud SQL serves the application, BigQuery serves the decisions. That is eventually like majorly for logging, for user information. You want to store platform user information. For that you can use Cloud SQL directly. But BigQuery is an analytics engine on that decisions, proper analytical queries. It can serve as a data to any kind of BI tools like Power BI, Tableau, these kind of this thing. So Looker Studio and all, where you can link those things directly. BigQuery tables you can link. That is how it works. Next thing we talk about, whenever you will talk about any kind of data warehouse, they will talk about indexes. How exactly BigQuery achieves scalability, how it achieves without having, because indexes are the concept of RDBMS, relational database management system, OLTP system. Okay, indexes are the concept of OLTP system. It is not available in OLAP systems. Any kind of OLAP data warehouses, it is not present. So it gives you columnar storage. So read only the required column, reduces the IO operation. Input or output operations are like reduced, and it improves the like compression also, because columnar storage, it is very compressed data. It is better data for big data processing also. Next thing is distributed execution. Distributed execution will be there. Thousands of workers process the data in parallel across the multiple machines. Next thing is partition pruning. We have partition pruning, like suppose we have these kind of data. 2024 data is here, 2025, 2026, 2027. These kind of data is there. So suppose I want the data only for 2024. I will only refer to this partition, that is called, and rest all partition will be ignored. Okay, it will not be considered only. So that is called as pruning, partition pruning. We are ignoring that. That is eliminates irrelevant data partition before query execution. That is the meaning of it. Fourth one is your clustering strategy. It reallocates your data, co-allocates your data. Like suppose you have a partition like this, partition like this, partition like this. You apply a cluster on a string column or something like that. So in this partition, on that column, it will be ordered. It will be reallocated. So efficient data ranges will be ordered properly, so that whenever you write a select query on this and write a where condition, directly it can get from where to where. It will be faster eventually. So that's why we use partition by and then cluster by. Okay. partition by and then cluster by. That is the key takeaways of the thing. Then as we talked about this thing already, partition by is partitioning versus clustering. Partition by is it divides your tables by date and time, reduces the scans for the time travel queries. It is very essential for your cost control. For cost control, very important. And every time it is the best thing to use your partition by. Whenever you will not use a partition by, whenever bigger tables are there and you are writing your queries, at that time it will take very long time, very high compute things, because it will be doing a full table scan that you don't want. That's why we write partition by. It applies first in it will be your first thing to be applied in the optimization. First you will apply partition, what date will be required, then on that column only you will write where clause, right? So that your data can be only selected data can be selected. Next thing is clustering. Clustering is something that is, it organizes your data into the partition, accelerates your where clause. Like you have to accelerate. Why? Because it orders the thing into the it reallocates the thing. Suppose this was the data 5, 3, 1, 2, like this data was there. You applied a column cluster by on this. So it will store your data like this 1, 2, 3, 4, 5 like this. So that is the meaning of a cluster by. It reallocates your data as per that. It reallocates your data means just assume it as what it sorts the data on that. If I showcase you one of the Google Cloud only, there is a documentation of Google Cloud clustering versus partition. There's a very good documentation to it. Okay, so as we can see on this, basically this is a diagram to it and how it looks like. Just to showcase you, this is how. So basically in the left hand side there's a non-clustered table. Okay, this is a non-clustered table. On this one here, this middle one, table 2, is a clustered by country. So whenever you do a cluster on this, it is arranging the same kind of data at one place. Okay, and when you do a cluster and partition, there was a diagram of cluster and partition also. So what a partition, like clustered column pe whenever you will do a partition, like you do a clustering and partitioning. Okay, like this. So basically it is a non-clustered. Orders table is a non-cluster on the left hand side, this one. Next what we did a cluster by on and non-partition table. All the data was arranged properly on a country, JP, KE, UK, US, like this. So now what we did, we applied the partition by on the order date. So now this is how the table was partitioned here, and then it was sorted also as per the data. Okay, that is the meaning of this. That is the meaning of this one. Okay, that's why we should use partition by then cluster by. It arranges the data properly. Okay, next thing, if you want to learn about data engineering from very scratch, from very zero, we have a DataX bootcamp. This is my own bootcamp. I teach about these things, and all the links in the description. The link of the enrollment is also there. WhatsApp support number is also there. If you want to ask about something, if you have some doubts about something, go and ask there. Other than that, we have a coupon code directly. You can use that and get enrolled. Very much affordable. Other than that, we'll be learning about all these things. We'll be learning about Python, Hadoop, Snowflake, Apache Spark, Pandas, SQL, then Databricks, Azure Data Factory, then the Google Cloud Platform. We have done projects, proper projects. We have done production grade projects, I can say, properly with the best practices we have applied. Definitely you can get enrolled, and we have Gen AI integration also. So definitely no need to worry about everything. Everything is job focused. So many people have already got benefited from it. So many people got placed from different background to data engineering, from non-data background to 4 offers in data engineering, from non-data background to senior data engineers. So much of things I have given to the people. So definitely you can get enrolled and get benefit from it. Next question is controlling the BigQuery cost in production. Whenever you talk about production jobs or live projects, they will always talk about what is the cost, how much cost it is taking. Cost is very important aspect. That is, you should never use select star everything, because it will scan everything, all the columns at once, not required. Next thing is use partition filters. Every time it will eliminate your data scanning. Partition pruning it will do. Okay, that is why it is important. Next thing is leverage the materialized view. You should always leverage the materialized view. Every time you should not use just views. Materialized views are something that also contain data. Okay, so that you can leverage, that you can get the idea of what exactly is materialized view to get an idea of that. Next thing is enable the result caching. Result caching is very, very important. Suppose you are querying the same kind of result every time, every 5 hours, 3 hours, 4 hours, or every minute you are doing it. What you can do caching on that particular window, and for 24 hours it will store that thing, and whenever you run it will give you a result from their cached memory. Okay, the identical results are there, directly you get the result. Next thing is monitor the query patterns. That is, in the information schema we already have a monitor properly. Go and see how much cost it is taking, what is the queries, what optimizations you are applying, all those kind of things you can see and understand about those things. Okay, so for performance it is very important, and this is a very big problem, that is schema evaluation, because schema drift can be there, schema evaluation can be there. Suppose today I have this many column, 1 2 3 4 5 column. Next, after a day what happened, some 3-4 columns got added again. This is called as schema evaluation. Evolve, schema is evolving, new columns getting added, or any column got deleted. Those kind of things are there. So we have to handle those things also. There are safe operations. We can add null columns. We can add nested records to the columns. We can change the required columns to nullable mode, zero downtime, backward, like directly you can do that. You can use Spark also to do that. Okay, so you should not remove the existing column, change the column data type. You should not do, because it can fail. You should not rename without aliasing something. Okay, you should not rename any kind of column, or if you are removing also, renaming also, please alias it properly. That is very, very important. Okay, be very careful. It requires careful migration whenever you're changing the column. Please be very, very clear about these things. Many times people talk about GCS, Google Cloud Storage, and BigQuery. What is, like, both exist. There's a different use case for both of the thing. First one is Google Cloud Platform, Google Cloud Storage. We talk about bucket storage also. It is a cost-effective object storage for raw and unstructured, any kind of data you want to probably just go and upload. You can upload this, because this is a data lake. This is a data lake, so directly you can upload any type of data. Any type of data can be uploaded. BigQuery is something. BigQuery is high performance SQL analytics engine. For structured data, it is firstly fast interactive results it can give you, queries it can give you, and it is for BI workloads, any kind of business intelligence workflows if you want to run, that can be done. And eventually it is like, it depends on the cost also. The cost of GCS is per GB it cost you, similar like BigQuery only, like very structured data is there, that's why. So minimal changes are there, so that kind of things are there. Okay, chalo, use cases. If you talk about GCS, Google Cloud Storage, for any kind of archival data, staging layer, backups if you want to store, that can be done. For BigQuery, analytics, reporting, ML, these things, that can be done. So majorly for GCS we use at an intermediate layer, as a staging layer, where you can fetch the data from any kind of source, keep it into the GCS, then while fetching, while reading from there, apply your transformation logic and all. So that is how we ingest the data, use the GCS. Okay. Then we talk about change data capture. Change data capture pipeline means anything getting changed in the source, directly it should be added or uploaded to the, like, near real time processing and all. That is called as CDC, change data capture. First thing is Datastream. It is Datastream you can use, that is called as log. It is log based. Firstly, real time and log based CDC is there. Second thing you can use, it is a event driven, any kind of like update, insert, these kind of things are happening, that is event driven. And it is a pub sub. Pub sub is also a service of this thing. Batch incremental loads you can do. You can do timestamp based extraction and all. You can build that kind of batch incremental pipelines, and you can do that. So that is the things. Production challenges are handling, see, as we talked about late arriving data. Late arriving data is something, right now you got some data eventually, and after 2 p.m. you got eventually, like majorly you get data at 10 a.m. Tomorrow you get the data at 2 p.m. Late arriving data is coming. So my pipeline was not running at that time. So what happened? The data got missed. That can be a problem. So we talk about how you can handle this late arriving data, out of order data, how you can handle. Deduplication for exactly once semantic layers. Then ensuring the independent write operations. We have talked about these things in the previous classes also. Definitely I'm not repeating those things. Just the GCP concepts what are there that I'm talking about. Dataflow and Dataproc. So there are two concepts, Apache Beam and Apache Spark. So Apache Beam, whenever we talk about data flow. Apache Spark we talk about Dataproc. Okay, that is a difference, major difference. Dataflow is something that is fully serverless. Automatic scaling will be there because it uses the cloud native this thing. It is cloud based only, so serverless it will be. Automatic scaling will be there. Unified batches are there and streaming will be there. Apache Stream models will be the Apache Beam model it uses, and pay as you go. All the cloud applies pay as you go. Minimal overhead is there. It is best managed for simplicity. Managed simplicity is there. It is best for that. Next thing, whenever you are talking about Dataproc is something, it is managed Spark and Hadoop system. Next thing is infrastructure control will be there. Spark code based migrations you can do. Then custom libraries you can, because you are using Spark. Eventually you are using Apache Spark. You can write your code. You can post on that. You can deploy there, and directly Dataproc jobs are running. Cluster tuning you can do. You can do manual scaling. All those kind of things you can do. Then maximum flexibility you will get because you can write your own code. You can write your own things. That's why it gives you more flexibility as compared to what? As compared to Dataflow. So eventually it depends on your decision what you are using and at what point you have to use. If you want Dataflow for simplicity, you can use Dataproc. If you want more flexibility, you want to use different kind of custom logics and all, at that point use Dataproc. Okay. Handling rate arriving data, as we were talking about incremental this thing, late arriving data, how you will figure out. First thing is you have to detect the thing. That is event versus processing time comparison using the watermark. There will be watermark means timestamp you will be appending, right? At what time the data is getting processed or getting, at that time you will also append one kind of current timestamp. At that time, what is the time? So you can get that particular thing. Next thing is reprocessing. Like when you reprocess, so late arrival data, whatever was processed, that will not be processed. Now whatever late arrival data came in, that will be processed after. That is called a reprocessing the data. Next thing is correctness. You can use merge into directly, and again you run the pipeline. From the scratch also it runs. It will not load duplicate data because you use merge into. Okay, merge into is one of the technique that is absurd. Like you give proper, when matched, then I want to just update. When not matched, I want to insert. These kind of like if else things you can go in. It is a SQL based thing only, merge into. Okay, that is there directly you can use. Next thing is your fourth one is your validation. Validation is something that is perform. You can perform data quality checks, reconciliation reports you can create, like implement strategies you can do. Implement strategies matlab you can separate the ingestion and event timestamp. You can design merge logics, absurd operations you can do. Then configure your this thing, your allowed latents, whatever the window at what time the data is coming in, that you can apply. So these kind of things you can do, and business impact your whatever late arriving data was there, that will be sorted. So securing the data pipelines, whenever we talk about security governance, we are talking about IAM. IAM is the infrastructure access management system. Okay, so at every cloud we have it, at every platform we have IAM. That is, it is a least privilege. It is a least privilege system where we talk about minimum permissions you have to give, service principals you can create, service accounts you can create, and user roles you can create, for which user you want which type of access that you can give. Then service accounts for separate kind of pipeline, separate kind of accounts you can create as per the requirements. Data set access level, fine graded BigQuery permissions you can get, row level security, column level security, all those kind of things can be done on BigQuery directly. Data warehouse it is, right? On all the data warehouses you can do that thing. VPC and encryptions, okay, that you can encrypt the data. That is also very important. Or virtual private connections you can create. Additional security layer can be there. Different kind of virtual private networks, audit logging, these kind of things are there, so that you can apply. Common interview mistakes that people do, that is treating BigQuery as a MySQL, RDBMS. RDBMS is not equal to, there is a difference. Please try to understand between the OLAP, OLTP. I have been taking so many classes on this. I have been teaching in the DataX very clearly how exactly these things are different. Definitely that if you can learn from there also, definitely from scratch. Other than that, ignoring cost optimization should not cost, like you should not just write a code. You should also understand how much time it is taking, how much cost it is taking to run that thing. There is no partition strategy that you are doing. Missing failure recovery. You are not having fault tolerance in your pipeline. Absent data validation or data checks are not there. That is also a problem. So exactly once the data is processing in GCP, You have to figure out these things. We already talked about deduplication logics and all, checkpointing and all. Definitely these things we have already covered everything from the scratch in data engineering bootcamp, DataX bootcamp, that you can enroll and get into it. Links are in the description. Use that and get into it. And definitely from scratch we have talked about so many things. So many people are already there in the bootcamp to understand, to learn about these things. Next thing is monitoring and debugging. Very, very important. Whenever a pipeline is running, maybe any failure is coming, okay, so there is a cloud monitoring, custom cloud monitoring, where the pipeline is running. You have a cluster monitor where you can watch all the problems. You have query logs, information schema stores all your query logs. You have slot utilization. Whenever you run any kind of this thing, okay, you go to the system. As of now billing is disabled, but whenever you go any kind of system and you run a query, suppose you run any kind of query, you run this query, okay, so whenever you run this query here only, like in this only, I think so it will not run, but let's show. Okay, so here basically you will get lot of information. You will get job information, you will get visualization, you will get JSON, you will get execution details, all those kind of things. So here basically all kind of compute, how much time it took to run the query, all those kind of things will be here. Execution graph will be there. So this is how you figure out how much time it is taking, what is the, how many slots, how many things it processed, what is the like slot time also I want to show. So here I can see everything I can see here. You can see na slot timing is there. So all these kind of things you can see. Similarly, cloud storage. In the cloud storage directly you can create the bucket, and in this bucket directly store the data. Other than that, we have BigQuery, already showed you. Dataflow is there where you can create your Dataflow pipeline template. From the template also you can build, or from manually also. If you want to start a very like custom, more flexibility you want in your pipelines. So jobs you can create via Dataproc, because it is a fully scalable Apache Spark, Apache Hadoop pipeline you can create, directly distributed pipelines you can create. That is also an advantage of it. So these kind of things you can apply and use it. Cost tracking, data freshness, these kind of things can be done. So how a data engineer thinks, a senior data engineer, whenever we're talking about a senior data engineer, how he thinks, that is, whenever you talk about senior data engineer, he should be aware about cost optimization, reliability. Reliability means suppose today it is running, if more data is coming in, whether it is taking, whether the failure is coming, it is able to recover it or not. Scalability is important. It can handle 10x growth or not without re-architecture. Migrations we cannot do every time, right? So we have to figure out that also. Maintain, we can maintain the clear documentations are there, testing is done, everything. Security is very, very top notch. So all those kind of things is very, very important. That is the thing. So production grade thinking will be required. These are the differences between the junior engineer and the senior engineer. Senior engineer will more focus on rather than just focusing on the code, he will more focus on ki failure is coming, how to correct those things proactively, how I can set up those things and all. So that is the difference between these people. Okay, so the final takeaways are, definitely you should be aware about all those kind of things: design decisions, recovery thinking, cost awareness, trade-offs. Rather than just running behind tools and tools, you should be exactly learning about technical depth of the things also. Very, very important. Technical depth, communication skills are very, very important. How you can explain those things in the interviews, that also matters. So this was all about the this particular video. If you have any doubts, please reach me out on the comments, ask any questions. Other than that, we have a DataX module. If you want to, DataX bootcamp, where you want to learn about data engineering from very scratch, from very zero. You don't know anything about engineering, you don't know anything about code, you can learn from there. Okay, from very scratch we teach. We have live sessions also on every weekend. We have so much of recorded content at any time you can see. We have communities where you can ask your doubts right away. Okay, 24/7. Other than that, we have Discord server. We have so many things, WhatsApp support, so many things are there. Definitely you can get those kind of understanding, everything. Interview focused modules are also there. Everything is there. So definitely links are in the description. If you want to take the decision, take it right away. Use the coupon code. This was all about it. Thank you so much. Bye bye.